The commutative property applies to AND, OR, and XOR, which means it doesn't matter which order they appear in the SQL statement. If you're asking A and B, that's equivalent to B and A. A or B is the same thing as B or A. A exclusive or B, exactly the same thing as B exclusive or A. However, not is not commutative. It's not a commutative property. A not B will not give you the same response as B not A out of a table. So here we worry about order of operation only for the not Boolean operator. The AND, OR, and exclusive OR operators, doesn't matter which order they're moving with comparing a pair of statements or a pair of conditions. It doesn't matter which order they're in. For not, order does matter. Within SQL statements or queries, we have to be aware of the order of operations, which is modified a little bit from the standard order of operations that you should be familiar with from mathematics and statistics. We can build complex SQL queries with many different operators used at once within the same, what either we call a SQL statement or a query. If you do build a very complex expression and it fails to work, then you use parentheses to modify the order of operations. Okay? The evaluation of the SQL statement occurs from left to right. It occurs first within the same level of precedence, the same order of operation, and then it proceeds down the levels of precedence from the greatest precedence to the least, and left to right within each level. And so what are the levels in ArcGIS? So this slide is all about and showing this. The ArcGIS order of operations, unless you use parentheses to change the order, this is the sequence in which things will be evaluated in the SQL statement, and they will be evaluated at each level for all of the statements that occur at that level of precedence, and do it from left to right within the same level of precedence. So first, powers and exponents, and then Boolean not, multiplication and division operations, followed by addition and subtraction, then the Boolean and, XOR, and OR, in that order, and finally the relational statements, less than or equal to, greater than or equal to, or not equal. So the order of operations that you see there, bear that in mind as you build SQL statements, and understand that within the same level of precedence, the computer program is going to evaluate your SQL statement from left to right all the time. Doesn't matter which level you're working on. If you have multiple power expressions, the multiple power expressions are going to be evaluated first, then Boolean nots, then if you have any multiplication or division, those, then addition and subtraction, and in order, Boolean ANDs first, Boolean XORs next, Boolean ORs after that, and finally, again, the relational statements. All right, so this is a little bit different from the standard order of operations. We're fitting in the Boolean statements where they occur in the order of processing for ArcGIS. So with that in mind, when you have a statement here, they're all Boolean. We're using parentheticals to separate out different portions of the statement and give an order of operation to what's occurring. So the top statement here, A and B or C, which one comes first? We evaluate it left to right. A and B is first, gives us a set. Then we do the or C part. Okay, that's going to give us pretty much the same answer that we get with the second one. A statement with A and B in parentheses, or C, will give the same answer as the first one, and so on and so forth. Looking through these, the different variations of the statements and which operator you're using. Okay, just keep in mind the order of operations is important, and it's important with Boolean operators too. If you're going to use those, and you have a complex SQL statement made up of those, understand how they're going to be evaluated. So let's consider and or again, and remembering with a SQL statement you're testing each of the features separate of each other. And we're seeing here wrong and right examples of using those two operators. Let's look at wrong first. So why is it wrong to say land use equals residential and land use equals commercial? It's categorical information. If it's categorical, then each individual feature or record in the table can only have one of those as its characteristic. It's either going to be residential or it's going to be commercial. Okay, so that's the proper use would be or. If you want to select land use, commercial. If you do and, it's going to fail. If you do or, then that's proper. That's the way to do it. We want land use to be this or that. It can't be this and that because it's categorical or nominal information. The second example is numerical. It's quantitative. So on the left, pop 2,000 greater than or equal to 5,000 or pop 2,000 less than 9,000. Well, how does that work numerically? We've basically selected the entire number line, which is, not a good statement. So we have to have both of those conditions applied at the same time. So we use and pop 2,000 greater than or equal to 5,000 and pop 2,000 less than 9,000. That'll give us a range between those values. The or statement selects everything quantitatively because everything can fit that. Okay, so I hope pay attention to the what these Boolean operators do logically and how they're working with categorical information and quantitative information, and which one is going to actually be the appropriate one to use for what you're trying to do. Here's another little test showing a couple of statements using parentheses to change the order of operations. So land use equals residential or land use equals commercial. That'll give us residential and commercial properties as a set, all of them. Then we look at the quantitative thing. So and though all of those then that have a value greater than 100,000. How is that different from what's below, where we say first the land use category is residential, so it selects all residential parcels. And then we have the or statement, or in parentheses, land use equals commercial and value greater than 100,000. So within parentheses, we're getting all the commercial properties that have a value greater than 100,000, and we're going to combine those with all residential properties. So there's a very different outcome depending upon how you choose to group these things together with your order of operations, in this case using parentheses, to separate out two different conditions. In either case, the first or the second, two different conditions, and then you're getting very different results out of the same table. Now we transition out of table-based queries and we start looking at spatial queries, relationships in space between attributes and variables and categories. So examples here using our Aspen stands again. Here are three major categories of spatial relationships: intersections, containment, and proximity, and questions that we might ask of the database. Does the road cross the aspen stand? Do polygons share areas or boundaries or not? Is an aspen stand located within a geological unit? Is a road within a geological unit? How many aspen stands are within 200 meters of a road or a mile of a road? Things like that. So, now we switch over into thinking about how space itself can frame questions and how we can get at that information within the ArcGIS program to query our data sets and then get spatial responses to spatial questions. So this is a list of our spatial operators when we select by location. Here are the different things that we can select by, and we will be comparing essentially two different data sets, one to the other, with one of these spatial operations to get some sort of a selection from the data. So we're testing relationships between two different things at a time, just like we might do if we're building a SQL statement. The target layer is the one that contains our features that we want to select. The source layer is what we're comparing it to. Okay, so this kind of works like the table relationships between when we're joining things together. The target is what we're interested in looking at, and we're comparing it to our source. So in this case here, aspen stands intersected by roads is the top diagram. So the result is the aspen stands, the target, that are intersected by roads, the source or comparison. In the bottom, we select roads as the target that are intersected by aspen stands as the source. So we're using the same two data sets, different order of formulating the query, and we get different results. Intersections occur, as we say here, when any part of one feature touches, crosses, or overlaps another feature, and that's the basic intersect tool. Lower on the choice of operators, we see a collection of what we call special cases of intersecting features, and the names of those tools should be fairly clear as to what they're doing. And if not, you can look up the ArcGIS help on select by location to get exactly what's going to happen with those particular tools. The one that you're going to use most often will be just a basic intersection, just the intersect tool by itself. But those special cases, sometimes you might need to use those. Again, it depends on what kind of a question you need to have answered out of your database. But most often, a simple intersect is going to be what most people need. Our containment operators are contain or within. So features from a data set that completely enclose all the features of all of another feature from another data set. That's containment. So features. So let's try some examples of the containment operators. With contains, one feature must lie inside another, and they may share a boundary. So for example, using this portion of Oregon, Oregon contains Columbia County. Columbia County is located on the border. It shares a border with Oregon, but it's within Oregon. Oregon contains Columbia County. Completely contains means that one feature lies inside another without touching the boundary. So using the counties as an example, Oregon does not completely contain Columbia County because they share a border, but it does completely contain Jefferson County. They do not share borders. So the containment operators known as within and completely within. Within is the inverse of contains. We're searching for things that are within them. So using the same example, Columbia County is within Oregon. Jefferson County is completely within Oregon. Okay, so they're slightly different, but we're doing the same thing. We're seeing whether the boundaries of one feature encompass another, or if one feature is found within the boundaries of another. So contains or within. They're both giving us similar types of responses, but we're phrasing the question differently. Proximity is how close things are to each other. So using select by location and proximity are within a distance of. So the operator is going to say, for example, here, volcanoes within 100 kilometers of an interstate highway. And that will be the selection from, in this case, a point location layer or data set from a linear data set or a line data set. So more spatial queries, selecting counties that contain the state capitals. So we get, using the 4 states, Washington, Oregon, Idaho, and Montana, which are the counties. We don't see the names of them. We don't see the data that may be in the table, but we see them selected. So when we select by location, the first thing we're going to notice on the map is that the features we've selected are highlighted in blue by default. You can change the color to something else, but typically that light blue will indicate that your selection found those records out of the table. On the right, I'm selecting counties within 200 miles of Denver. So Denver being a point location, and we're selecting counties around them. Okay. So there we have contain and within. More examples of that. Another couple of examples focusing on hydrography, or the spatial distribution of rivers. Selecting counties that intersect rivers on the left, or selecting rivers that intersect Texas on the right. Now, it should be fairly obvious that that's what's happening here, but let's take a minute and think about this. Here's an example where I should point out that as spatial scientists, as folks training in geography, in geographic analysis, we should be familiar with our study area, and we should know by looking at this particular map that this can't possibly be true. There are far more rivers, and it gets into the idea then of actually how do you define what a river is. And in geography we would be more apt to call it a stream, but anyway, there are more rivers than what we see here in across the United States. So the data set that we're actually working with, we should know, is incomplete, and it's only showing us rivers at a particular scale, and probably only rivers of a particular size, and not all of them. So I'll just use that as a nice aside here. When you are studying an area, you should get familiar with it, and you should get familiar with the data that especially depict the landscape, and know whether or not it is accurate, precise, and truthful, and actually giving you information that makes sense. Okay, but as an example of how to do queries, we're looking at intersection here as the query.